Budu has been with the laboratory since '98. He is actually a graduate from the University of Calcutta in India, came then to the United States and got a master from Kent State University and then his PhD from Purdue University. Since '98, he is with Oak Ridge National Laboratory. He's still working on his 2-year plan here at the laboratory. Hasn't quite finished that yet, so he has some trouble with execution, I guess.
Big time.
Since 2001, he's group leader of the Geographic Information Science and Technology group. In 2010, he became a faculty in the Bredesen Center and is very active there nowadays. And in 2011, he became a corporate fellow for all of the research he has done, and he continues to drive our science agenda when it comes to big data, geographical information sciences, and things like that. He's very active in a number of directorates and interacts a lot with the driving the lab agenda forward. With that, I'm going to quit speaking here and let Budu talk on big data for energy and urban mobility. Thank you.
Thank you, Klaus. Thank you. It always used to be cookies and pizza, but ice cream works just as well when it's 90 degrees, right? I was impressed that Klaus needed 3 of my bios just to make sure that he can introduce me well. So thank you again for showing up. You know, Robert asked me a couple of months back if I would come and give this talk that he heard me give about a year back, and this talk is absolutely nonsense. It's pretty much, there is no substance to it, but so that's why I guess Robert said, you know, it's a Friday, people have nothing to do, so maybe you can come and give a talk and people can waste their time again. So I plan on exactly doing that. I'll waste the next 1 hour of your life by talking about, you know, what I think about urban dynamics, big data. We talk about population and why in transportation, you know, some of the things that we are doing at Oak Ridge National Laboratory are so fairly unique in the world that it's, if I have to say that, you know, what are the sectors that we will make a profound impact on, it's going to be transportation and health. Those are the 2 of my top favorite, and then energy comes all along. So this is, you know, about me rambling around what I think about data, what I think about how we are using data. Is this something novel, or is just an absolute, you know, wild goose chase? So first, let me define urban dynamics, right? So you probably have seen this video that Time and Google created using Landsat satellite images that shows the scars on the planet, okay? There is clearly, we are building. I want you to notice that every time you see this city's building, you will see water somewhere close by. We have not been able to do a very good job of building nice cities away from water, right? And you will soon come to see the craziness that only we can think about, which is Las Vegas, right there. And watch what happens to the water, okay, as Vegas grows. So before you finalize your retirement plan in Southeast Arizona, I want you to think about what you should be drinking responsibly, okay? So, you know, in a way, urban dynamics is at the planet scale. We are interested in understanding how urban footprints are changing at the scale of the planet. And at the lab, we are making lots of progress towards that. We are creating science and technology towards actually doing that kind of thing. So big cities, which we are all familiar with, brings big data with it, right? Because there are lots of moving parts in it. So UCL was one of the first pioneering institutions that, you know, because of their existence in London, they started, you know, the CASA, which is the Center for Advanced Spatial Analysis with Mike Patty, and they've been studying London ever since and creating all kinds of data from their transportation network, their electricity network. It's a fascinating story. And then soon, we have been seeing this new surge of, CUSP at NYU. Chicago has this Urban Center for Computation and Data that's jointly with Argonne. IIT Bombay has created Center for Urban Science and Engineering, and then now we have, books that are looking at this new science of cities. So Mike Batty, who is known as one of the key personalities or scientists, scholars who have done this thing. Mike wrote this new book called New Science of Cities, and he's also on the UDI board. He will be here from UCL next year. So it has really emerged as this new area that we are all grappling to understand how it is. And partly because we somehow are all associated with urban areas and cities, partly because we like it, and partly because we are very intimidated by this whole urban issue, that what's going to happen in the future. So when I say that, there is a lot of data that's coming with this evolving world that we have. Traditionally, if you go back in history of data, we started creating data by observing things, right? So we were observing, and then we were measuring. And then we started doing experiments, whether that was in the field or it was in the lab. We did lots of experiments, we started collecting data, and then came computers. So once we had computers, then we started creating models and simulations, and we started generating lots more data sets. For example, climate. We are creating lots of simulations, outputs of climate, and creating lots and lots of data that we can use later on. These things are stored somewhere in archives that we access with various degrees of efficiency. But that has not stopped us from generating more data from the environment. So because we are very good at sensors, right? So if we have a large group of people at the lab who are experts on creating sensors and measuring, observing and measuring things out in there. So sensors have gone up. And then finally, we have figured out that we are one of the best sensors on this planet. We, the people. And we have these gadgets like smartphones and Fitbits that we carry around, and we collect a lot of data about ourselves and our environment that we choose to share and not share. Sometimes we do it by choice, sometimes we do it inadvertently, but we are basically putting it out there that people can make a lot of use about. So it's really a community that is working towards these kinds of data sets. So UDI, as an institute, is trying to create this cross-disciplinary platform at the laboratory where we want to bring data and cyber and computation at the heart of all of you who are interested in some domain, transportation being just one of them. What are some of these novel things that we can do? Now we have access to lots of new data. We have access to large computers and cyber infrastructure, so we can communicate wirelessly or over wires. So there has to be some utility about it, right? So that's the UDI's role. We are focusing on 4 different areas. One is population and land use, because that's a unique strength of the laboratory, that is a unique capability of the laboratory. Then sustainable mobility. So Amy Rose, where is Amy? Amy, she is the one who is in charge of that science pillar on population and land use. Andreas Malikopoulos, who's also the deputy director for the UDI, the Institute for Sustainable Mobility. Brennan Smith, I don't know if Brennan is here or not, from Environmental Sciences Division. Brennan leads the Energy Water Nexus. And then Femi, I saw Femi somewhere hiding, in the back. He's our research focus team lead on urban resiliency. So most of you belong to, based upon your interest, belong to one or more of these pillars. And so those are the 4 people who you probably interact with. If you haven't started it, Ice Cream Social should be the first time you should get that dialogue going. It's okay. So I'm going to define what I feel big data, and especially big urban data, is, right? There is big urban data, in my view, which is data on urban environments that are generated because we can now observe, sense, and measure things better than any time else. Okay? So that's the, it was things that were always there. We just didn't had an opportunity to measure and create data out of it. Okay? So it's essentially a sensing and measurement success. But then there is this, what I call urban big data, which is generated by modeling and simulations of urban environments, urban infrastructures. And then lots and lots of transactional data sets that are all of a sudden emerged because we have this cyber infrastructure. So with my phone, I can immediately access all my transactional data sets, my doctor's visits, my bank account transactions, my credit card transactions, everything. I have access to that data using my phone through these applications, right? That is fairly new. We didn't have it for the longest time. Access to that kind of data sets is fairly new. And the other one is social media, which we all participate in some form or the other. We collect data and we put it out there. Like I might tweet. I have become an expert in expressing my emotions in 140 characters, by the way. And I would say deep things like, well, it's bloody hot out there. How many of you have seen tweets like that? Right? I just do it because I felt like doing it, but for somebody, it became data. They can look at where I am, where I'm tweeting from, and they know that it is very hot. Now, very hot may not mean anything, but I might have said that it's cannot believe it's 94 in the middle of September. I just put out a whole bunch of data that can go out and help science. I said September, I know where I am, and I said something about the temperature. And I also said something that says that it's not expected or it's not normal, right? So all these kinds of things that are coming to us, what is the opportunity, right? We have always been curiosity driven, so we want to know, can I answer some questions that I observed out there? Like, why did this thing happen? Is there enough data to explain, right? But where we really are interested is understanding, can all these things help me predict something? Like the stock market, right? Well, where is Huina? She's one of our Leon Russell fellows. I thought I saw her back there. She did her work looking at Twitter trends and mood predictions in the stock market. And she got attention from Nobel laureates in economics who thought that that had some merits to it, right? So look, let's not kid ourselves. We are all here as individual consumers, right? And we are all very value conscious. So all these things I can tell you that what kind of wonderful things can happen, you will always come down to a value proposition. Is this worthwhile doing for me? So if I have to come and tell you, hey, there is a value for big data, you will ask, are you going to tell me something that I did not know before? Is there new knowledge? Okay. Second thing is, are you going to give me the answer that I am going to now get from this that I had to spend more time or more money getting it in the past? So I'm looking for some value. And the third one is that it has to work for everybody, from an individual like me all the way to an enterprise like, let's say, the NAB, right? The other bounding conditions that I always remind people of that every question that we ask has a life expectancy. We do not ask a question saying, I would like this answer to these questions sometime in my lifetime, right? We don't do that. So there is a time aspect to it of by when we need this answer. The other thing is that you do not need a lot of data to answer all the questions you have. Sometimes very few data sets, Google Maps, and you see this status of the transportation infrastructure in this red, blue, green, or red, yellow, green sort of representation. They're basically looking at a few people's Android phones telling them what speed they're traveling. So on a road segment, then you have 3 people traveling at 15 miles per hour. How many people think that the rest of the people are driving 85? You don't, right? Similarly, the way we create infrastructure also lends for small data. I can tell you that when I look at the electric grid, I only need a few people to tell me that they lost electricity. And I can with high certainty, I can conclude that all these other people does not have electricity because that's how the grid is laid out. So you cannot have if these people do not have electricity, right? So it's an infrastructure design issue. So I've probably shown this to you, but there are sort of interesting things embedded in these kinds of big data things over urban things. And one of the things that got attention, a lot of attention a few years back was this, can you see where the rich are who are using iPhones, which was at that time the most expensive thing. So this is, how many people guess which place is this? This is Atlanta. It's going to go in alphabetical order, so I'll make it easy for you. So the red is iPhone, okay? The red is iPhone. This is Atlanta. This is Chicago, very good. This is Houston, LA, New York, Washington, D.C. Okay? Why do we see these crazy patterns? Isn't it crazy? I do not know. I'm not trying to explain to you why, but I'm just saying that people started observing that there are these incredibly interesting patterns that are embedded in these kinds of data sets. And this is not a US city. So the purples are BlackBerry users. This is Jakarta, Indonesia. So there must be a reason everybody is on BlackBerry in Jakarta, right? It has to be. The data, that's what the data shows. We do not know why, but that's what the data shows. So it starts generating new things that we did not know before or we did not observe before. So here is the transportation story starts. And I've been an expert in transportation for a long time because I drive every day, I go places every day, right? So just like everybody in this lab, I'm a transportation expert. But when Dana Christensen was the associate lab director, he had us pursue an exercise. And I came across this dissertation research by Weinstein. And so these are from Boston Public Library statements recorded about the cities. There are statements from the mayor, statements from the planning board, statements from citizens. People wrote letters to the editor in the Boston Globe. And look at this language, right? The city surveying department spoke of the stupendous congestion problem, while the writer, an anonymous letter to a newspaper, spoke of the Gordian knot of traffic congestion, right? City planning board said that the congestion was strangling the city, while a newspaper editorial described city conditions approximating the impossible. Okay? Speaking of traffic, in search term as unbearable. Interestingly, all these were done and written between 1895 and 1910. Okay? So this is not, in fact, this is an, 1925 this is the cartoon that came out in, I think it was Current Affairs in Boston Globe that was talking about congestion in Boston. So it's a social construct, right? We are all used to it. We have all lived with transportation as the data. So, so why do we care about it, or in terms of data sets, why do we care about it? And I want to quickly touch on this one thing that I go over and over and over. If you hate congestion and if you're concerned about atmospheric emissions and climate, the one easy way of all of us contributing to a simple and elegant solution is we all stayed home. If we do not move, if we all stay at one place, there will be no congestion, not many people will drive, and the emission will go down, fossil fuel burning will go down, and we will make a measurable impact The challenge is that we cannot do it. We have not, as a species, we have not found a way to do that very well. In fact, if you look at the last 20 years worth of data on expansion and explosion of internet and telecommunication versus travel, it will blow your mind, because the more we have been connected, the more we have started traveling, because we are curiosity driven. So it's not good enough to look at a place from Google Earth. We just want to be there and experience that place, right? So it is an amazingly interesting thing. So one thing, if I have to hedge my bet on it, I would say that whatever we want to do for the future, for future community and society, mobility must be a priority that I have to balance along with environment and energy. You cannot keep people static. Okay? It won't happen. There are some interesting data that shows Costas Goulias had at Santa Barbara had a study where he showed that when Silicon Valley heavily promoted work from home as a practice, everybody predicted that the road congestion will go down, and it did, because everybody could see that it was taking them less time to get to work. But what happened is, the unforeseen consequence was that all of a sudden people realized that they don't have to go to work every day, so they could buy a house that they have always wanted to buy. So they moved far out from the city, and in 2 days they were doing more driving than they were doing in 5 days. Okay? So the net effect wasn't in our favor. So that was the challenge with transportation. So I bring it down to this issue about people. That one of the things that we have done at the lab very well is we have learned, and we have developed over the last 20 years, are very unique, sophisticated ways of understanding where people are and how do they move around, which drives everything. So this is, you have seen Washington, D.C., this is a diurnal variation of population, and you can think of this as an energy demand map, right? This is where all the energy is and water is needed, because that's where people are congregating at some point. So we are doing this for, as I said, 20 years. Our best data set globally was at kilometer resolution. But at a kilometer resolution, it's gross generalization of population, right? It's fairly spread out, peanut buttering. So what we are trying to do is we are trying to get the world mapped, people of the world mapped in very high resolution, 90-meter resolution, okay? And the way we can do this is a very simple approach that we are taking, and I'm harping on this because if you know where people are, you can start understanding this, how life works, how activities work, and how they impact our infrastructure. So I will give you, and this is a whole talk by itself, but so I'm going to quickly run through this. We are taking satellite images that are 50 centimeters in resolution. We are mapping every building that you can see. We are getting attributes for this building about how tall these buildings are, what kind of activities these buildings have, and then something about what kind of population densities these people in buildings might have, and combining all these to create this very, very high resolution population data. So 90-meter parts of the world. So where is the scientific advancement and processing of big data, right? So this is what NASA Modi satellite told us, that this is where a city is, the red pixels, right? This is what Landsat TM tells us where that city is. It's a 30-meter resolution. And this is what we are generating out of the algorithms that we have generated and the computers that we have. So now we can map cities at unprecedented resolution and speed. So we can take a city like Addis Ababa, Ethiopia, which is about 800 square kilometers, and then extract every building that stands there in about 15 seconds or less. Okay? And then we have another approach of mapping building outlines using convolution network and deep learning techniques, where we are mapping building outlines at that resolution. So at the end, we will change the estimate of how many people actually live on this planet. And these are the people, so every one of you who's associated with the lab should be very proud that this is a unique achievement for us, for the rest of the world. We have mapped people who have never existed in our history of our civilization. They have never been found before. Okay? It's an incredible accomplishment for the laboratory. All right, so population dynamics is where transportation comes in, right? Because people walk, but most of the time transportation is to get people from point A to point B in an efficient amount of time. So we can do this kind of tracking of people using videos, cell phones, and social media. And then we also have, model-based assessments, so activities and in variable space and time. So in a short period of time, evacuation scenarios versus over long decadal scales, how will people move from if sea level rises and you get flooded. So one example is, can you mine these kind of video data sets to get dominant paths of motion? That how are these people are flowing through a transportation. So that's a railway station in, I believe it's in New York. That how can you mine these to understand how many people and which directions they're flowing. And you can do very sophisticated kind of modeling where, in the bottom right, you are seeing 300,000 school kids individually model every 5 seconds walking to school and back in the city of Philadelphia. And the reason EPA was interested and they paid us to do this is because they wanted to know what do these kids breathe as they walk to school every day for their life, right when you have peak traffic on the streets and the emission level at the street level is the highest. So it's air quality, transportation air quality issues. As part of the urban initiative, there are a few internal projects that we are working on. Teja Kuruganti and people from his colleagues from Ken Tobin's former organization. No, Ken is still the division director till October 1. Here is something very unique that's going on, which is, create a sensor that picks up the communications between a phone and the cell phone tower. And if we can pick up that communication, then we can use that presence of a phone as a proxy for a person. So we are not interested in who that person is, who they are calling, what they are talking about. We just want to know where that person is and if they're moving or not, right? This data set is incredibly important for transportation as well as everything else that we want to model in the real world. The challenge has been that data is always captured by your cell phone provider, and they cannot quite share it because all this personal data is attached to that thing, that your name, all your payment information. So this is going to bypass that entire privacy concerns and the data proprietary concerns and give us an enormous amount of data sets that we can use for modeling. This is another data sets and model that we have created, which is looking at future population. So this is not projection of US population in the future. This is projections of locations of US populations in the future. Where will people be in 2030 and 2035? So Jake, Amy, and others who have created this model called Landcast is allowing us to understand future US population distribution. So if you want to know what's going to happen to your transportation infrastructure in 10, 20, 30 years, this is very important data sets that we can use in our modeling and simulation. And I'll show you that one. So one interesting part of big data is it allows us to identify the chasing tail of this distribution, okay? And it became famous in the health sector by this one article that Atul Gawande wrote. He's a cardiologist at Mass General, in the New Yorker about the hotspotters. And what, if I can summarize this, in Camden, New Jersey, 1% of patients accounted for 30% of the medical costs. That was what that data analysis found. And what they found is that 80% of that 1% lived in 2 buildings. They were tall 2 buildings. These were poor people. They could not hold jobs. They had poor diet. They were all overweight. Every time they tried to work, they will break something. And they all used the ER as their primary care provider. So what they did is they created an organization of nurses who just focused on those 2 buildings and made the biggest impact on cost and infrastructure, right? And every infrastructure has that issue. This is a study I think that Berkeley was involved in. It came out in early 2014, which basically said that we commonly believe that if you move people into dense urban environments where people are not really driving, and you have accessibility to services within walking distance, we will make an impact. It is true, but what this study showed is that if 20% of people choose to live in the suburbia, they will do enough driving to undo all the good the other 80% are doing. So it's the tail that we have to deal with, not what we have, right? So Lucy Hutera, who's at Boston University, they have done this incredible study about mapping carbon dioxide coming out of tailpipes across the nation and showing how transportation impacts air quality. And so very, very, very rich data sets that are coming to us for doing something. So I talked about modeling and simulation of transportation systems, right? And I like using this picture or representation that Argonne has for a model they call Polaris, which essentially allows you to understand how cars and vehicles move around in urban environment. And it has sort of components that every activity-based models and simulations should have: travel behavior, performance measures, physical systems, information flow, all that good things, right? And they have one demonstration in Chicago, which is very good, powerful. And Department of Transportation is clearly, as Klaus will validate, that they are very impressed with Argonne's claim for modeling transportation in Chicago. So I don't know how many people know this or not, but one of the first person I started interacting with when I first landed in '98 was Oscar Franzese. And I was fascinated by what Oscar was doing. He was right around the corner, and I got interested in this sort of transportation simulations. And then I kept inspiring people, saying, I think we have enough cool data sets and models and simulations and capabilities that we can do something that nobody else can. And the goal was, let's not create a simulation that will work only in one city. But let's create a simulation platform that we can take anywhere. And at the time, it sounded crazy, right? Because what do you need? You need a global street network, you need a global population distribution, and you need some models of traffic engineering that you could integrate with those few things, right? So a few years back, we finally, and I have to thank people like Cheng Lu, Oscar Franzese, Jim Nutaro, James Lee, Hussein, Gautam. We were a first entity in the world to achieve a global scale simulation capability. So we can simulate traffic anywhere in the world, okay? Including the 79 countries where you drive on the right side of the road, which is left. And I will tell you another thing. One way of validating that we were doing something that nobody else is doing or attempting to do was Wei Lu, who was our star postdoc working on this and created some very, very powerful simulations. We lost him to Uber. So when Uber comes looking for your people, you are doing something good. Okay? So it's a success story for us. So why am I interested in this? Okay? So it should have been a little bigger, but here is how we are using this in urban dynamics. So city of Cleveland, Tennessee, and most of you know where it is. I was teaching a class at UT, and I started interacting with Greg Thomas, who's their city planner. And he came and said that the city of Cleveland, Tennessee has a 2035 land use plan, and they have a brownfield in the middle of the city, and they have no idea what will happen if they execute that land use plan, because the land use plan is based upon how can you build anything that will add to your tax base, right? So here's what we did, or at least the class did. So there are people like Pranav, Eric, they did. So they took our 2030 future population distribution, they took Cleveland's future land use plan, and they took the simulation model that we call TUMS, Toolbox for Urban Mobility Simulation, to create a simulation for what would happen to Cleveland in 2035 if they executed that plan. And what it showed them is where are they going to have these types of congestion if that plan was actually a reality, right? So now we can do these kinds of things anywhere. It's not going to help them assign traffic lights, but it gives them, before they do anything in the surface, it gives them an idea about, is this a good idea? What is going to happen, right? And to be able to do this at a global scale is pretty remarkable. So Andreas is, our LDRD PI that is just wrapping up on algorithms that optimizes traffic flow for connected and autonomous vehicles. So there is this beautiful outputs that are coming up where in the future, all the cars are connected and automated, and they're working with each other. You don't even need traffic lights, right? So one of the things that I was at a meeting at the National Academies when somebody asked is that, okay, what about the mischievous pedestrians who will jump onto the street? Because those simulations do not have any people in it. It's just cars. But that's not reality. There has to be people in the cars, and what would happen to this, right? So you know that the car manufacturers are already working on these. Volvo has the new V or S80 or V80 that the cameras can identify actually bicyclists and pedestrians like in their view, so it warns you on that. But I have been thinking about this, right? Can we do something about it? And in this new initiative called Transportation as a System that DOE has embarked on, which will see a remarkable growth in anything that we have seen in this. This is something that nobody has talked about yet, that how do you model this together? Not the vehicle systems, but people together too. So Benjamin, where is Benjamin? I saw Benjamin. Benjamin Hernandez, and he came to us from Barcelona, and he's part of our force. Benjamin says, well, I have been looking at how do people move on the surface with some kind of behavior, and we can do this for areas, for people pedestrian modeling, right? Which is fairly remarkable that we can do these kind of behavioral simulations of people and where they are, so you can replace, and so this is what I call a pedestrian model, right? We can start, so we have something that we can start integrating with the vehicle stuff. There is another one that is very interesting on transportation, which is when do you not have any transportation network, what happens then? So transportation kind of immediately in your mind, you're thinking there are roads, but Devin White and Christine Safi and Andrew Harden, they're working on this project called FEET, from everywhere to everywhere. So if you are in part of the world where there are no roads, but there are a bunch of people, how do you know how will they travel? Okay? So this is looking at, it turns out that this is deeply embedded in anthropological principles where water molecules and people show very similar properties by we internalized this habit of minimizing energy expenditures. That's why we always look for the shortcuts, right? So it's a simulation, and you give cost path, the associate cost with the path, and then you come up with probabilistic representation of where people might travel given there is an open terrain. So we call it the people-shaped approach. So I'm going to show you a few more data things because that's going to be interesting. So I talked about all these modeling and simulation things that we have been doing, right? So what's the big utility? So Cheng simulated all the workers in Knox County, and this is slightly dated because this was a 2007 LDRD we had, all the workers in Knox County on their behavior of going to work, from home, going to work. And so we have the simulation platform, we did that, and then here's the part of the output, okay? This is how many miles a worker drives to get to work each way. So it's anywhere between a mile to about 30 miles, okay? And this is, the data is at the block group level. Here is how much money those same people make. So darker the green, you make more money. And if you combine those two data sets, and this data is from Census, how much money these people make, right? So in this map, darker the green, that means you make more money and you also drive a lot. Now, which by the way is not a ground-shaking discovery. We had long known that that's what happens. Rich people drive more. Rich people make more phone calls. But you can quickly see where the river is, right? You can map the river by looking at the dark green. But I thought this data was amazing. So I kept asking, okay, so how does DOE know what will happen next year? Because we are betting on plug-in hybrid and connected vehicles and all these kinds of things, right? So let's look at the data. Total work commute trip was about 179,000. The simulation said average travel time was 19 minutes. Census says it was about 21 minutes, which was kind of a validation, cross-validation. It's not too shabby, 19 and 21. But the last number is the magic number, okay? What is the total distance people drove? Vehicle miles traveled, VMT, right? It's about 1,860,000 miles, right? So you have two options. If you want to make an impact on energy, you have two options. One is you drive that number down. You drive that number down, we will gain on energy. So how can you drive that number down? You move activities around. So you move schools closer to homes, move work closer to home, or move work closer to, or home closer to work. We move, but we do not know very well how to move these concrete structures and then all of a sudden, like Lego blocks, change a city. We have not been able to do it. Although outside the US, some countries are actually doing it by developing and disseminating. London, in fact, UCL has talked about moving out of London. So what is our option then if we cannot do that very well? We said, as Department of Energy, we are going to invest in technology that gives me more miles per unit energy. So we have CAFE standards, how many gallons or how many miles per gallon, or how many miles per unit charge. So we are trying to optimize this number right here, and we have to get more miles per unit energy, right? So let's assume 10% of Knox County drivers will buy a new plug-in hybrid vehicle next year, right? The question is, who are these 10% people and what difference will it make? So if we do not have any spatial information about these people and who they are, and if you just run kind of an averaging simulations, at the end you will say 10% of that mile is eventually going to be impacted, right? That's what simulations will lead you to. But let's look at another way of looking at this data set, which is, what if I could pick that 10% of new plug-in hybrid owners from one of these income groups? I do not know how. I'm not claiming I know how to do it. I'm just saying that what if we could do it? It turns out till about $80,000 per year income level, if you get those 10% from that income group, you will only impact 15% more miles than this in this number. However, if you can get the rich to buy into the plug-in hybrid vehicles, you get 25 to 30% more miles impacted. So the question is, do the rich really care about the gas prices going up by quarter? Right? You don't know. So, but the trick is, if we have to do this, we have to find a way to get these people to adapt these new kinds of transportation energy technologies. So we ran this kind of a model. It has a fancy name. This was developed originally by David Green called MA3T. And we took that model took that paper and implemented this model, except we added a new dimension to it called the follow the Joneses effect, which is if I see a lot of my friends buying plug-in hybrid, I will most likely buy a plug-in hybrid. If Robert and Klaus says, do not even think about it, I will say, no way, I'm going to buy one, right? Because they're the experts. And these kind of models, all of you know that they have some dynamic variables, static variables, and you simulate out that who is going to give you a spatial representation. So here is one output of such a simulation. And what it shows that from 2010 to 2030, which parts of Knox County are most likely to see these plug-in hybrid owners? Now, why is this information important? One is, as Jack Welch says, that these are the transformer busters, because they will all go home and plug in their cars and bust the transformers. So the local utilities want to know where to harden that infrastructure. Okay? And at the same time, if you can anticipate where these owners are going to be, you can start creating infrastructure that incentivizes these people, saying, well, I have places to plug in. Like if you go to Smyrna, all of a sudden, I was shocked that McDonald's has like 5 parking spots for plugging your vehicle, right? So does the Cracker Barrel at Crossville intersection on I-40, which I have a picture of a Hummer being parked there. I do. Okay, I would show you another one interesting thing. So this is a space-time footprint of our daily lives. And the simple question was, what percentage of workers of a county commute to work in that county or any of the surrounding counties, one of the surrounding counties? Okay? It's a simple question. And my hypothesis is, and I have the roads, and I know the origination point of their homes, and I know their point of their destination. So the hypothesis is that my daily routine activities of a county population are restricted within that county and its surrounding counties. It's my spatial footprint of my simulation that I need, right? How many of you are exceptions to this rule? Is there anybody who is exception to this rule that the county you live in, you don't work in that county or one of the surrounding counties? There's one, Ramki. So one person in this entire room. That's a pretty good data, right? And my hypothesis is that what I do in my lifetime is actually within that footprint. I go to work there, I go to shop there, my kids go to school there, everything is in there. So if I have to simulate an urban environment and transportation system, that's a good bounding box, with the exception of, a couple of trips to the beach. The other thing I also asked is, I have always asked, is that what is the standard gas size of the gas tank of an average sedan? Does anybody know? 15, 14, 18. Okay. So what I found out that apparently there is no standard. It is somewhere around 15. It depends on the car manufacturers. But apparently, there is a magic number of 300 miles. So 300 miles per full tank you have to be able to go. So I found out that that's the number that is dictating our research in batteries, that we are all shooting for a battery that has to go 300 miles. And I'm asking, why that number 300? Because we just all saw that all of us except Ramki live and work in that boundary. And I have the data to show you that if you darker the green, that means the more percentage of those people fall in that category, okay? So it's a very skewed distribution. So why do you want a 300-mile car when you are in New Jersey? You will never, ever drive 300 miles, right? So we have always treated this car as a mobile property that has to go with us no matter where we go. So we have to think about locally adaptive strategies, that how can we tailor my car based upon where I am, or tailor my house based upon where I am, move away from standards, okay? We have never done that before. And this is probably the time when the data analysis is only going to give me that confidence that I will, 99% of the time, I will not need a car battery that needs to run more than 150 miles or even 100 miles, right? That's what the data will show me. Okay, I'm quickly running out of time. So I told you that, moving away from the averages. So we are collecting a lot of data, like wearable technologies are the latest hot things, Fitbits and all that good stuff. I still haven't received this jacket that it's $250 that even vibrates when you slouch. It keeps you straight. It collects all kinds of biometric, right? So biometric smartware. So we are all collecting all kinds of data. We can collect all kinds of data. And one of the things we are all obsessed about that how much are we walking? Because the American Cardiology Association has said 10,000 steps a day, right? I have one of those. I'm getting part of the 10,000 right here. And here is my data from some time. This is what I was doing. Actually, it turns out that those 4 days you saw that I did extremely well. Right here. Can anybody guess what was going on? It's hard. I was actually in London. I was not trying to walk 10,000 miles or 10,000 steps, but I ended up doing it. Never complained, right? So urban design and form has a way of how we do it. So we are intrigued with this disappearing public-private boundary, right? So I will put a challenge that all these wonderful things, that advancement that has come in transportation engineers have very little to do with it. I know I'm going to take some beating about it, but it is not. We do not have, as Robert would say, that they're working on what is the next generation engines, right? But that is not internal combustion engine. So everything that has come from internet and telecommunication. So here is some data that shows the 10 states typical yearly automobile ownership cost from Bankrate.com. This is AAA that says this is how much money you will spend for owning a car. Average mid-size sedan is $8,876 in 2014 and broken into the 6 categories. So it's, we can quantify these things. All of us can because we have this number, right? So there comes Uber. Uber basically will tell you, depending on where you live and how much miles you travel. So that's an important data you need to have, which we can generate for you with all this data and modeling and simulation. And it will tell you whether you are better off. It's like buying or renting, right? Are you better off buying a car or you should just Uber it all the time? The interesting thing is, this is catching up on the coast where most people are getting rid of their cars and they are Ubering it. So after Googling, Ubering is the new verb. So the question is, and I heard this first time from Ruben, who's our DAS for transportation, and Ruben said that he got rid of his car and all of a sudden he had $800 freed up because he didn't have a car payment. And he said that, I was Ubering, I Uber every day. But the amazing thing is I'm not spending $800 a month on Ubering, but I'm not sure where the other rest of it is going because it's not in my bank account. So I'm spending it somewhere, right? The moment you have disposable income, you spend. But if you spend and you buy stuff, are you actually reducing your energy and carbon footprint? Maybe you're buying now all of a sudden buying things that are increasing your carbon footprint overall, that you were better off just driving a car. We just do not know, right? So that's where the new things will come on. So less reasons to own car, and now Uber has created this pool pass. They did a very elegant experiments last couple of months where they give 10,000 people across the nation unlimited Uber pool passes. So you pay $40 a month, and you can take as many Uber trips you want. You know why they did it? They wanted to see what is that upper limit. If you had unlimited option of traveling, how much could you actually do? It's a very important number, right? And they have now generated it with that Uber pool concept. So let's talk about CAVs. This is, I worry about CAVs because if DOE becomes overwhelmingly successful with connected autonomous vehicles, it's a disaster for society. And I'll explain in a moment why I mean it's a disaster for society. So right now, the cabs, they're based on this principle that cars are and they are communicating with each other, okay? So each car is communicating with the other car, and they are all in sync. So what if I put people in between? So instead of cars communicating with cars, cars communicate through people with other cars. Is that acceptable? Does that make sense? Right? But isn't that what Waze is about? That's what Waze is. It allows cars to communicate with other cars through humans, and we are facilitating that part. And you will be amazed how much data gets generated by Waze users. So last Monday, I was driving back from Murfreesboro, and I had my Waze open, and it says, "Watch out, animal spotted on road ahead." And within 5 seconds, I saw a couple of deers on the next to I-40. Within 5 seconds. Okay? It is an enormous amount of data that drivers are generating, and don't ask me how, but we are doing it. In fact, we are doing it to the extent that it is having a measurable impact on our infrastructure and urban environment. In fact, the city of Boston actually uses Waze to manage the city's transportation now. Okay? And Nashville is talking about the same thing. But you think about it. These are tangible metrics. 82 million hours have been saved by this kind of communications that are going on. So everybody is now going into ride sharing and Uber pooling, which is very, very interesting. So there is a social and behavioral dimension, right? So it goes, and this is what I found intriguing. So we are walking 10,000 steps. We are all agreeing that walking and biking are good for health and all that stuff. So here is 2008 to 2012 census collected data of how many people use what kind of mode of transportation to go to work in the US. And I am sure that none of you are shocked with this figure that 86% of people use car, truck, or van to go to work, right? So work at home is 4.3%, 5% public transportation, bicycle is 0.06, walking is 2.8. We have a long way to go, okay? What is even more depressing is the trend. So 80 census showed that 5.6% of the population were walking to work. And 2008 to 2012, that number has gone down 100% or 50%, right? It's 100. There is not a very good news on bicycles either, right? Over 20-some year period, the number has gone up by 0.1. So we need different kinds of strategies if we have to do this well. So the French did an interesting study, an experiment. What they did is in Paris, they said that they will pay people to bike to work. So it's like per mile, whatever we get, whatever 38 cents or 48 cents you get for driving, we get reimbursed. So they said, if you're biking to work, we will pay you at that same level, right? All of a sudden, they had 120 people were biking to work, and that number went to like 230 something. So it was like a 100% jump. You would think that it was great, right? And it turned out that 70% of those 110 more new people were actually already in a carpool. So it wasn't really an impact, right? So one thing that they concluded from that is that free parking is the kiss of death. If you provide free parking, you can forget about the rest. Nothing is going to happen. But more importantly, they found another thing that is, I think, is even more interesting, which is they said that people get associated with the mode of transportation early on. When you're in your 40s, you don't all of a sudden become a bicyclist. Okay? So if you go to my son goes to Farragut High School, and I found that the most popular vehicle to be owned is the Jeep. That's the coolest and most popular. If you look at the distribution of what these young drivers are driving, SUVs are one of the big things because everybody wants to be high, their kids up top with a big vehicle, right? This is the same as the cocaine model. Do you think they're going to downgrade themselves into a bicycle? Right? I don't know. But coming back to data, and I'm done. I'm coming back to data. One of the things that I always wonder about that, we are doing all these kinds of studies about collecting data from us and planning a future that is 20 years out based upon data collected from us who may not be driving in 20 years. So the key research issue is that how do you collect data from the future homeowners and the future drivers? I've been asking this question at DOT. They're doing this behavioral study, but it's people like me. If I define my kids' behavior based upon what I do, there's nothing more wrong that can be done, right? So I don't know. I don't know the answer, but this whole integration of cyber infrastructure becomes a very important part of future transportation because we just do not know. So it's an interesting time. I'll show you this one last example because this is very interesting. I'm very excited about it, and Femi is leading this project with a couple of other people, Teja and others. All of you have heard about this LiDAR data set, that 1 meter, 3-dimensional data that the city of Knoxville has collected with the county and KUB. 4 or 5 years back, we took the 300,000 buildings in the county and calculated how much solar power they can generate on the rooftops. What you're seeing now is on the left is how, as the sun moves around, what gets radiance of sunlight and what doesn't, where the shading, right? And what we have done is we have calculated the solar potential of every street. Now, you can say, well, do we need to generate electricity out of the solar on the streets? Maybe we do, because if we have wireless charging, as the cars are traveling, maybe the streets can become part of that infrastructure where they are generating the electricity, right? But in the near term, what we are trying to do with the city in partnership with them is the city has $180,000 of their budget for 2 snow or ice events when they have to spread brine. And they have this sophisticated engineering on their 23 trucks, which is, as the truck moves, the valve opens and then they spread. And if the driver hits the brake, the valve closes. And what we are trying to demonstrate is that why would you want to spread the same amount of salt on a piece of road that is already getting a lot of sunlight, as opposed to the roads that are shaded, they are close to the schools, and if you cannot get the ice removed, the schools cannot open and everything, right? So how can you stretch this $180,000? So this is precision de-icing. So we are very excited about this project, and nowhere in the country is something like this going on as a partnership with the city. And the economic benefit is tremendous because we are trying to understand how, so it's integrated with climate data. So you look at what kind of 5 days worth of preceding days you had, what could be the road temperature, and also what is the slope. So every time I come down that Watt Road exit, every time it snows, I avoid Watt Road because I have to hit that slope, right? If I can identify those areas and treat them first, I can reduce the number of accidents. which is directly relevant to the transportation's metric, which is safety and property damage, right? So make a big impact. So this is kind of novel data, novel analysis. You know, we learned this from our solar experts who does solar energy, right? So I'm going to leave it there because that's kind of sums up what the Institute is trying to do. You know, get people who know about different areas, bring them around data and computing, and then come up with things that we can make a difference in every sector, including transportation. All right, I've ran out. So thank you.